Alright, so here we're going to dive into composite figures, and really a composite figure, it's composed of more than one thing. It's just two basic shapes that are added together. So you see in this house, we have a triangular prism just on top of a rectangular prism. So when we're finding volume, we're thinking about really just breaking it down into its pieces and adding those back together. You'd find the volume of this guy, find the volume of that, and then you add them together. That's the full volume. Surface area is a little bit trickier. When you have the surfaces of these three-dimensional figures on top of each other, there's parts that are going to be excluded. So thinking about on this cone that's on top of that rectangular prism, we have this circle that's overlapping in both. That is not a part of the surface area. The surface area of a figure is just the outside faces. So you would deal with the top of this rectangular prism, each of the sides, the bottom, the lateral surface of the cone. You would not include the base of the cone, because that's actually just being covered up, and you would actually have to subtract out an additional circle. So I'm thinking about that circle that's covered up on top of the rectangular prism. You would really have to subtract out the area of that circle, because it's not really a part of the surface area, but if you find the surface area of just that rectangular prism, it will be included. Same kind of thing on this one. I have a cone here. You think about the lateral surface of that cone, lateral surface of that cone, the lateral surface of the cylinder, and actually none of these bases are included. They're all covered up. So you can find the full surface area of each of those and then subtract out the parts that you need to. Or you can literally just break it down into the faces that you have to find, the lateral area of each of those added together. Sometimes it's not that simple, but really in this case it would just be the lateral surface of each of those figures put together, because those are the only exposed surfaces or exposed faces in those figures. Alright, so in this example we're seeing that BC is congruent to CF, so that is congruent to that, so that's also 12. Really, this is a square base on that rectangular prism. We're trying to find the volume of the prism. This entire shape is a prism. Really, a prism is any base stretched by that height. So this whole thing is really just one prism. It's also two prisms broken down. We can look at that as a rectangular prism, so I'm thinking about the volume of that rectangular prism plus the volume of this trapezoidal prism, which uses the equation capital B times H. That is the area of the base, which actually makes these two equations identical. Really, length times width is also the area of the base. So this is just the general form of any prism. This is specifically for a rectangular prism. So I'm thinking about those two broken down. Actually, we could also do this as just one big prism. I'm going to show that in a second. I'm thinking about the length and width. I'm going to label this as the length, this as the width. So that's going to be 12 times the height of the prism. That's the distance in between the two bases. So I'm thinking about that as the base, and then on the back side of that, I have another square there. Those are my two bases. The distance in between those bases, from there to there, that's 80. So that's the height of the prism. Same kind of thing for the trapezoid. To find the area of the base, the area of the trapezoid is 1/2 times the height times B1 plus B2. So that's really just adding up the two bases, the top and the bottom, or B1 and B2. I have to do that step first because that's in parentheses, so I'm going to do 1/2 times the height of the trapezoid. So straight up and down there, if I see that this entire distance from the top all the way down to the bottom is 20, and this part of it, that part, or that part, is 12, so that's 12 out of that 20. This part has to be 8. So the height of the trapezoid is 8, base 1, and base 2. I'm just going to add those together in one step here and get 34. So now I'm just going to multiply those together. 1/2 times 8 is 4, times 34 is 136. So the area of this base, that capital B, is 136. The height of the prism, it's always the distance in between the two bases. So we have a trapezoid in the front, there's a trapezoid in the back. The distance between those is 80. We're going to multiply 136 times 80 and find that the volume of the trapezoidal prism is 10,880. The volume of the rectangular or square-based rectangular prism is 11,520. Then we could add those together and find that the full volume is 22,400. Our units are centimeters, so it's going to be centimeters cubed. there is actually maybe a slightly faster way to do this. So a prism can really just be simplified down to just this equation, where this, capital B, is the area of the base. So I can actually think about this whole thing, this entire face, as the base. Find the area of that entire thing, and then just multiply it by 80 in one step. So instead of using just 136 there, I would use 136 plus the area of that base, which is 144. So that's the area of this and this together. So that whole thing is going to serve as the base of this prism times 80. That would give you the exact same volume there. All right, we're looking at that same shape. Now we're trying to find the surface area. So again, there's a couple different ways that you could do this. You could actually just look at each individual face, find the area of any exposed face there, any part of that surface, and then add those together. Or we can look at the surface area of the entire thing, each of these separately, and then subtract out the parts that we actually don't want to include. So each problem is a little bit different. You might want to decide on your own method, really whatever you're more comfortable with. On this one, I'm going to find the total surface area of both of these, and then subtract out that face that's covered up. So I'm thinking about first the surface area of a rectangular prism. That's 2L, 2LW plus 2LH plus 2HW. Basically 2 of each of the faces because it has opposite sides that are the same. So I'm thinking about this as my length, that is my height. Oh, sorry, that's my width. I'm going to keep this as my height because that's the distance in between what I'm imagining as the two bases, that base and the base in the back. That's going to be my height. So 2LW plus 2LH plus 2HW. So we're going to multiply first and then add up each of those three, and we get 4,128. So that's the surface area of that rectangular prism, including that face that we're eventually going to take away on the bottom. The surface area of any prism is HP plus 2B. So this is the lateral surface plus the two bases. H stands for the height in between the two bases. So I have a base in the front and a trapezoid in the back. Those are my two bases. Connecting those two is this length of 80. P stands for the perimeter of the base. So I'm trying to add up these four sides, and actually there's something that is missing from this problem. This is an isosceles trapezoid. It really needs to be. Otherwise, we can't really find the missing sides that we need. So we're looking for the perimeter of this trapezoid, so we really need to find that side. I'm going to use a right triangle to do that. I'm drawing an altitude there. I know that has to be 8. This length is 12. From there to there is 12. The entire distance from top to bottom is 20, so that part has to be 8. This base is 12, and if this is an isosceles trapezoid, these two triangles on either side are congruent, so this part is splitting up the remaining 10 evenly into just 5. So now we have 5 and 8 as my two sides as A and B. So 25 plus 64 square rooted gives me 9.43 for the length of that hypotenuse there. And same thing for that one. Really, all of this is just to find the perimeter of that trapezoid. I'm going to add up those four sides. 12 plus 22 plus 9.43 twice gives me that the perimeter is 53.86. So that's the perimeter of the base. Capital B stands for the area of the base, which we actually just found when we were finding the volume, so that's 136. Now you can plug into each part there, 80 times 53, sorry, it's 52.86. 52.86 plus 2 of those bases. So when you multiply those out and add them together, you find that the surface area of the trapezoidal prism is 4,501.1. I'm just going to round that to the tenths place there. So I can add these two together and get that the total surface area is 8,629.1. Unfortunately, that's including more than I really want to. Right now, that's including this face on top of that trapezoidal prism. So that's including this 80 by 12 rectangle. And this is actually including that same face. So we're really counting it twice when we don't want to be counting it at all. So I'm going to subtract away 2 of those, minus 2 of those rectangles, that 12 by 80 rectangle. So it's going to be this minus 1,920, which is 6,709.1. Our units are centimeters, and we're talking about the surface area. We're talking about literally the number of square centimeters that it would take to cover that shape, and it turns out that that's about 6,700. All right, here we're looking for the volume of that prism. So I'm going to actually just count this as one big prism. I'm going to find the area of the triangle, put it together with the area of that rectangle, and then use this 6 as the entire height of the prism. So I'm really using this equation for the entire thing. Even though it's a composite figure, I can really piece those together and count this as just one big prism. That only works if they have the same height there, which is 6. So I'm actually going to substitute that in right away. My height is 6. The area of the base, that's 3, so is that. So the area of that rectangle is 15. We have this 3.2 that we actually don't really need. We might need that for surface area, but not for volume. I'm looking at 5 as the base of that triangle. 2 is the height of that triangle. So 1/2 base times height would just tell me that the area of that triangle is 5. So the full base of that shape, those two pieces together, is 20. That's much simpler than finding the area, or sorry, the volume of each of those separately. Just thinking about this as the whole base of that shape, and it's stretched into the third dimension using that height. That's really all we're finding there for volume. So that's 120 meters cubed. All right, what is the surface area of that composite figure? So I'm looking at the surface area of that rectangular prism on the bottom and the surface area of the pyramid on top. Actually, this one I think I'm going to split up differently. I'm going to find each of these faces instead. So you could find the surface area of that, full surface area of that, and then take away the square that's on the top of the rectangular prism and the bottom of that square base pyramid. I'm just going to break this down into its faces. I have that one. Length times width for that would be 20. There's another one on the opposite side. Can't see it, but on the back side of that, we have that same face. So I have 20 times 2. Actually, it's going to be times 4, because I really have this face that's identical. This face and the one on the back side that we also can't see, that's another 20. So I have really going around the outside of this, like the lateral area of that rectangular prism would be 4 times 80. I also have that face on the bottom, which is 4 times 4. So I'm going to add in an extra 16. I'm not counting the face on top because it's covered up by that pyramid. I'm also not counting the base of the pyramid because that's covered up. So now I'm just thinking about these two plus the lateral area of that pyramid. So we're going to find that using 1/2 LP. L is the slant height there. So here I'm going to need to find that slant height. Right now I have the straight up and down height. This is really H. That's the straight up and down height going from the peak of that pyramid down to the base there. So that distance is 6. When this is a square base pyramid, that is forming a right triangle here, where this distance, it's halfway across that pyramid. So the whole way across there, from the front end to the back end, that's 4. This part has to be 2. I'm drawing that because I need to find this slope side of that right triangle. So I'm using 6 and 2 as my A and B, and I'm finding the hypotenuse there, the C, in that right triangle. So the length of that slant height is 6.32. This P, the perimeter, stands for perimeter of the base. So the base of this shape is a square, really just adding up those 4 sides. So that's going to be 16. So the lateral area of that pyramid is 50.56. Then we're going to add in the 80 and 16 plus 96 equals 146.56 inches squared.